Okay, so why does salt melt ice, even when it's already freezing? Let's get into the chemistry.
You see it all the time on icy roads. It's actually a pretty cool property of solutions. All right, here's the plan. We'll start with pure ice, then see what happens when salt crashes the party.
So first up, pure water. At 0 degrees Celsius, its molecules form this superorganized crystalline structure.
This attraction, it's called hydrogen bonding. Think of it as the glue that holds water molecules together.
And that bonding creates this beautiful open crystal lattice. It's actually why ice floats.
Okay, now let's introduce our disruptor, good old sodium chloride, or table salt. Water molecules, being polar, literally pull the sodium and chloride ions right off the salt crystal.
And these ions don't just wander off, they get completely surrounded by water molecules. That's hydration.
So now you've got these hydrated ions just getting in the way, blocking water molecules from linking up.
So here's the key difference. The ions disrupt the whole process, making it way harder for that ice lattice to form.
And this phenomenon isn't just about salt. It points to a much bigger concept in chemistry.
Right, and for any exam, this is crucial. It's a colligative property. It's all about the number of particles.
Freezing point depression is actually one of 4 colligative properties, and they all hinge on this same idea.
It's literally a numbers game, and this is why electrolytes, like salt, have such a huge impact.
See, one little unit of salt actually breaks apart into 2 ions in water. Double the trouble.
And you can see the effect right here. Double the particles from salt means roughly double the freezing point depression.
So to get that salt water to freeze, you have to pull out way more energy to overcome that chaos.
And that's why we say the freezing point is depressed. The water stays liquid at colder temperatures. So, for your exam, salt dissolves, ions disrupt the lattice, and the freezing point drops. Simple as that. Which leads to a great question. If 2 particles are good, would a salt that makes 3 be even better?